Shake on it. All right, cool. Let's move on to the blank page. And if you already got this, just be quiet and let people around you get it, or help them out. Do what you gotta do. Be a good person. 3 on the mixed units. So, fun fact, 1 inch is equal to 2.54 centimeters. Who knew that? Who figured that out on their problem set? Because they were like, I don't know this conversion. Maybe I need this. That's important, probably because that's the only, well, it's not the only way. It's one of the most probably common ways you're going to get from feet to centimeters, because that doesn't naturally occur. Like, you don't know that conversion. But I know this is not squared. I will square it as I need to later. So this is number 3 on the complex units. Right? Yeah, okay. So 23.6 feet squared. Ignore the squared for a moment. Just think of it as feet, and then your brain's going, okay, how do I get from feet to centimeters? I can't go straight there. So I know how to get from feet to inches, and there's 12 inches in 1 foot. And then separately, I know I'm ignoring the squares for a moment, separately, I now know how to get from inches to centimeters. So that is our next conversion. So that is one, I expect that you will know inches, like 1 inch is equal to 2.54 centimeters now. We'll use that a lot more often. But there's some other ones that are in here that are kind of out of the world, and I'll tell you those in your test, no worries. But once you set up your process and you see the foot squared, this has to be squared, 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 squared. Every number and the unit itself will be squared. The only thing that's not squared is this very first one, because I didn't give it to you as it was squared. So as you walk through the process, everything will cancel. Feet squared, inches squared, and centimeters are left. Boom. Who got this? Thumbs up. A couple of us. Like, very few of us. Okay, cool. 4. 4, I'm pretty good. I did this one yesterday in class for warm-up. Okay, 5. 5 all set up, but this is one where you're only going to be squaring. No, that's right, okay. You're only going to be squaring the unit that was the converted unit, or the conversion. So the number 5 on the complex units says this squared. So if this unit is squared, then the next conversion will also be squared. So kilometers squared to meters squared, ignore the squares for a moment, just set up your conversion like normal. Kilometers has to go on bottom, meters has to go on top. What's that conversion? I hear it. 1,000, right? 1 meter, oops, sorry, 1 kilometer has 1,000 meters in it. And since this kilometer is squared, you also square everything here. So that does make a pretty large number as you go through. So kilometers will be squared and they cancel, meters will stay, and you'll get your answer. I'm setting up work right now. You guys have the answers in the bottom, you can check as you go. And I'm moving quickly because you can see the numbers have been requested. So on like 6, okay, I know I can do 9. 9 for sure, because that's not fair, because I give you miles. Maybe 10. Let me start with 9 for a minute. So 9, the conversion is 1 mile is equal to 1,609 meters. That is one I do not expect that you'll remember, and that's okay, but that's going to be the only way you'll get from miles to meters. So use that for that purpose, but I'll give it to you on your test if you need it. So the question was 35.8 miles per hour. And whenever you have a fractional unit to start with, you just got to pick if you're going to start with numerator or if you're going to start with denominator. It really doesn't matter. You just have to pick one to start with, the other one you'll do on the tail end. So if the question for this one was to go to meters per second, I'm just going to go ahead and do the mile first, because I can know the direct conversion between mile and meter. So 1 mile has to go on bottom to cancel, and the meter, I told you right here, is 1,609 meters. So the miles are already done, they're out. So then your final step, or maybe 2 steps, will be how do you convert from hours to seconds? Did you guys do that in 1 step or 2 steps? 1. So some people are like, okay, I can figure out how many seconds are an hour. Easy. Or you can go from hours to minutes, minutes to seconds. And that's also fine. So let's just do in 1 step then. The hour over here needs to go away. So I have to put it up here, right? How many seconds are an hour? Okay, so it's 60 times 60, because there's 60 minutes an hour, there's 60 seconds in a minute, so that's 3,600 seconds. And that's good. I got meters left. Oops, sorry, hours cancel there. There you go. Meters are left. seconds or less. And if you don't do it in one step, you'll do it in 2 steps, from hours to minutes, minutes to seconds. So, okay, I'm rambling. Number 10, I think really the only thing that maybe you were concerned about is the centimeters cubed to milliliter. Here's that conversion again. You guys remember that one? The 1-to-1 ratio. 1 milliliter is equal to 1 centimeter cubed. If you took a cube of liquid water, it would also measure out to be 1 milliliter. So that's the only thing I think you would need on number 10 that you are concerned about. Yes.
I had just one more quick question about Code 3.
Yeah.
How did you what did you put into the calculator
To calculate?
all of them?
Yes, you did have to square all of them. So not this first number, so this would be in your calculator, 23.6 times 12 squared times 2.54 squared. So as long as that first one's not, you're in good shape. Yeah.
And number 10, what should the answer be? Because it's not only
Number 10. Oh, oops. It should be. So 10 should be 24,000 milligrams per milliliter. Is that the right one? 24,000 milligrams per milliliter. So yeah, and like in the future, what I generally do is the day after I take up the homework, I'll put the answer key online, which is just my work. You just have to read my chicken scratch, and you guys can always, when I give your homework back, you can always check over things that I didn't maybe go over in class with you, but I just threw my entire answer key online for your benefit. Okay. All right, I'm going to scooch over to the word problems ones though. So number 3 on the word problems, the particle moving. Again, word problems they're intimidating at first because you're like, oh my gosh, there's so much random information I don't need. You need to look for the 3 things that matter. In question 3, a particle moving through a gas at a speed of, okay, this is important, 45.8 meters per second. Strikes the wall of the container, bounces off, and hits the other wall 25 centimeters away. And then it says, how long does it take? What unit is asking for if it says, how long does it take? Say again? It's asking for time, right? It's asking for seconds. So that is our question. All right, I got a couple people doing some side conversations. You guys finish that up real fast. If you can explain something to someone next to you, take about a minute to do that now. I'll stop for a moment because you guys are probably need to pay attention. So if there's somebody next to you who can help you with the question, ask them now. Are you Joe's partner?
I'm just like
Write down what we're doing. Take good notes from him. If he turns in something, you get, or if he turns something, tell me what we're doing, okay? Alright, take like 10 more seconds. Alright, back up here. Stop your conversations now. Appreciate it. Just kind of helps so I make sure everybody's getting the attention they need from me and from you. Okay. So if we see this word problem, you don't need to read it again, right? We have everything we need here, and that's how you should always consider the word problems. Because if you keep reading it again, you're gonna like confuse yourself. I promised you, this is easier. So if you're looking, you see this is our given. This is our starting point. You have to start with the 25 centimeters because otherwise there's no way to use this conversion factor because the centimeters and the meters don't match. So you have to convert to meters first to employ that conversion factor. So in your head, you're going, okay, meter and centimeter, because centi is from the bottom. There's 1 meter, which contains 100 centimeters. So that's able to cancel. And then now you can employ the conversion factor. But do I write it exactly like it is? What do I do? Flip it, right. So the 45.8 is on the bottom, because that's what carries the meters. So the meters will cancel. And then 1 second on top. and then it's something like point zero, what is it, point zero,
Or just 2 zeros.
2 zeros? Okay, that's not a decimal. 546 seconds. Okay, so it's basically saying this gas particle is moving super fast because it's moving, 25 centimeters in that many seconds. But your process is always trying your best to use dimensional analysis. So that's what somebody else told me. I may have, might have slight dyslexia sometimes when I plug in the calculator, but this has been living on this paper for about 5 years. I haven't changed it on here yet, so sorry. But it's really close, right, to whatever you got in your calculator, or whatever it says on here. So let's just call that one slip, okay? Moving to 5. 4 and 5 are very similar. You needed to look at the densities of those and compare those. If you got 4, you can do 5. I'll come back to that one later. 11, blah, blah, blah. What's the density? So the question is, what's the density? So if you know that densities, what's density's formula? Mass over volume. If you know that the density of ivory, it says the volume is 14.5 centimeters cubed and mass is 26.8, mass over volume. Again, if you know your formula, you can plug that in very easily. At 12, minimum volume of a tank that can hold 795 kilograms of methanol. Right there, it doesn't look like you have enough information. It doesn't, but if you look at the table above, you'll see that density of methanol is given to you of 0.788 grams per centimeter cubed. And that's the density of methanol. So if that's the density of that, and it says you have 795 kilograms of methanol, then you're noticing that there's a relationship here. She's not 100% able to be used directly yet. So the question is volume. Basically, you're setting up another relationship with density. You could set up a proportion. I'm trying to stray away from that so that we're comfortable with just the process of dimensional analysis. But this is going to be your starting point. This is your end. Well, volume, I'm going to say we can call that centimeters cubed or milliliters because I don't determine which one you need here. So, using our thought process, 795 kilograms, I can't use kilograms, right? I don't have kilograms in my conversion, so what do I do first? Perfect. And 1,000 grams live in 1 kilogram. Right, so we're consistently using that. So the kilogram can cancel. Now I can take this, plop it right there, right? Exactly like it is? Right, you have to put the centimeters on top. And that 0.788 grams on bottom. So then your grams do cancel. And centimeters cubed is how you can record it in that or in milliliters, but they're one and the same. Alright, I'm going to scooch to 16 because I heard that one pretty loud and clear that you need that one. A lot of the ones with density is a version of something like this, where you're converting to a new unit and then using the density, or you're simply calculating density. But the word problems, the ones like 16, 17, 18, those are going to be something similar to something you'll see in your test. Okay, so the test is you have like 30 to 40 multiple choice, which is so I'm going to tell you this now, and I'll tell you again later, but just make sure with me. The test is like 30 to 40 multiple choice. It's generally stuff like from your reading guides, from your notes, from vocabulary, kind of more qualitative stuff. There'll be a little bit of numerical things in it because like this unit happens to have a big humongous chapter on math, like the metric system. Sig figs, a little bit like that. But then the free response where you'll have your written workout will be like compare and contrast chemical and physical changes. You do an explanation, right? It'll be show me your work for questions like the top of here. Maybe you'll have like 5 that are easy conversions with squared units or just the simple prefix ones, and then maybe you'll have 3 or 4 like the word ones that are like 16, 17, 18 here. And I had a couple people say, where can I get more word problems to practice? We did not do basically any of the word problems from your dimensional analysis lecture notes that were on the sheet that was like two sheets in one. So we did all the sig fig on one side, and then we started a little bit on the other side, but we really did a lot of practice from your problem set together. So you have a lot more accessible to you, and I can always put the answer key up online before the test to help you with that as well. Okay? All right, so 16. Here we go. This one is weird because it asks for you to use a percent. So the question it says, how many moles, so question, how many moles of NaNO3, which let's just call that Bob, okay? How many moles of Bob, because you don't even know the name of it yet, are in 35.6 grams of a solution that is 25% Bob. That's what it says, right? Well, then you're like, okay, 25%. I know that's just basically 0.25, and I can use that at the very end. Or you can actually think of a percent as a fraction. So you can think of this as 25 grams of this stuff, just that stuff, because it's 25% that, over 100 grams of your total solution. Let's say like solution total, something like that. So that's all. Oh, no, sorry, there's one more conversion factor. 85.0 grams per mole of this stuff. All right, so you don't need to look at the problem anymore. Don't worry about like what even is asked about. This is all you have. So if you see this percent and you're like, okay, got this conversion factor, and you see this one, what is your starting point? It has to be the simple fact, right? The 35.6 here. It's really hard to start with the conversion factor generally. So 35.6 grams of solution is what I'm starting with. You know I have to cancel grams of solution, which is the next conversion factor. The 25 one, right? Because it's the only one that has solution in it. This is that Bob, that sodium nitrate there. So I can't use that yet, but I can later. So using the 25 grams, I got exactly as it is. It's perfect. 25 grams of this thing over 100 grams of solution. And I need that solution or solution total because I need this grams of solution to cancel with that. All right, done. Now I've got this grams of NaNO3. I can't get to moles yet, but I'm getting there. What would have to go here? Can you guys see everything? Mole, right? So I know that this one has to be the conversion factor used because mole has to come into play now. So that 1 mole, I'm flipping the fraction. 1 mole goes on top, and the 85.0 grams of NaNO3 has to go on bottom because this grams of NaNO3, and this one has to cancel. And they do. And that's it. Right, we're 2 moles. Boom. That was a hard one because a lot of the verbiage was like new to you. But if you pull out the facts and then throw the question away, I think you can put your pieces together. Goals. Okay? So I think I can't remember the percentage or what the answer to that one is, but you just have it there for you. All right, take a breather. You have about 1 more minute. You ask somebody else a question about your problem set, but I'm going to take them up in a minute. Because I want to see where we are so we know the guide. We don't think it's good. Pass it that way. Alright guys, we pass this up and over to Jake. Up and over to Jake. Then pull out 2 pieces of paper. We're going to go to the lab, and I explain it very clearly first. Sorry. My little boy.
I can do one side and do the other side.
Alright, write this at the top of your paper. One of your pieces of paper. Write that at the top. I can do dimensional analysis all day, but I don't know if you get one dimensional analysis all day. So we are working. Maya, stand up, girl. We'll do some leg lifts. Who's been sitting in most of your classes all day? Poor babies. Poor babies. Okay.
I've done like 5 labs today. I don't know about you guys.
All right, we're going to do 2 more, okay? Okay, we are getting up in less than 5, but let me explain to you the process of how you're going to pace yourself in your lab. Because I always feel like sometimes it's common sense to say, like, okay, Riley, I need you to work on this. Christian, I need you to do this. And then like, we'll kind of come back together and talk at the end, like that discussion piece. But sometimes you guys just like, are you doing this? Or am I doing this? So just making sure we can kind of spread the wealth, okay? So chromatography is a means to separate a mixture. Is a mixture a chemical combination or a physical combination? Why? There are no chemical bonds between the stuff in the mixture. Maybe like the compounds, but not the entire mixture. So this is just going to be a simple chromatography experiment. We're going to walk through the results at the end, but I got to see the results, right? So basically what you're going to be seeing is that we'll start off with a mixture. And it's just a permanent marker that has dyes all mixed together. So think of them laying on top of each other. And over the course of about 30 minutes, the solvent that we're going to use is going to use capillary action and crawl up paper. So it's going to seep up into some paper. And as that seeps up into paper, the layers start to remove themselves from each other, and they just separate. So that's what you'll see. Maybe not this many colors, but you'll also see in the end, your dye that started at the very bottom will separate out like this. And after that, you'll be measuring the length or the distance that this dye traveled, and you'll be talking to me about why some things traveled farther than others, using this little calculation, which is on your paper, no worries. It's the distance traveled of one part compared to the distance traveled of the other part. But let me show you what you're going to set up, because you're going to be sharing data with some group members across the table from you. So first, when you get back there, read the lab, write your purpose statement. So go ahead and make a note to yourself, purpose statement. You guys, some people have pink Sharpies, some people have blue, black, whatever color was given to you. And you're going to have to use your Sharpie in 2 different settings. So that's what said both trials is completing using that one dye. And I'll show you the setup on the next slide. But basically, I already have these things cut for you. You're going to approximate a starting line and a finish line. And the starting line is going to be where you put your big dot of dye. And the finish line is where the solvent ends as it travels up the chromatography paper. So you're going to see that. You may have done something like this before with like a spinach leaf. So after you've got this ready, you're going to set up your beakers. So let's say Jake's group's doing water and ethanol with the purple Sharpie, but Lexi's group's going to do water and isopropyl alcohol. So when you're one group, you're not doing all 3. You're doing water versus one of the alcohols. Cool? That way we use less solvent and it goes a little faster too. But at the end, you'll be looking at other people's results to kind of make some comparisons between the alcohols, because different alcohols have different effects on permanent markers. So that's what this says. You'll set either this in water, water and ethanol, or water and isopropyl, and then you're going to have some colored paper. You'll just take your results to mark it up so I can see what your data says, because other groups are going to need to see your data. Now, that takes about 30 minutes. We're not going to sit and twiddle our thumbs and look pretty. We can do that, but let's do something else too. So on top of that, you guys are going to be working through, I'll leave this up here when we get to the data section. You'll be working through some introductory notes on the periodic table. You can scan this QR code if you want to. I also have them dispersed at the labs, or you can visit it on my website, because the periodic table, intro to the P2 is what it's called, it's going to give you a preface to something that we're going to do later with a blank periodic table, and we're going to like color this baby up, literally label everything possible in here, possible, because it's got a lot of information that I need you to be able to read just based on its location. So we're going to do that towards the end, but I want to see if we actually get to that. Okay? So lab, set up, then scan the QR code and take the notes when you get to the stopping point. Okay? All right, bye. Same lab groups as last time. Yes, you need safety glasses. Yes, you need safety glasses. I haven't moved one.
Raise your hand if you have, and say some big glasses like this. Do you have any blocking ones? Look at this. Close your eyes. Okay, you're good. I just want to see if the two ones are
Ask me what? Yes. if you could shape it so that it doesn't, you want it to sit in the bottom, like touch the bottom but not lay in the bottom. If you can adjust the size, that's fine.
Hey guys, give me your attention in 5, 4, 3, 2, 1. Okay, great. Eyes right here. I can see the back of your head. I want to see the front. Alright, cool. So this little strip, it's my lab assistant who cut them and they are not perfect. It's okay. You need to just make it consistent across both of yours. So if you did 2 centimeters from bottom to, it says about 8 centimeters from the origin to the finish, just make it work for your size beaker because it cannot lay in the bottom. It has to just touch the bottom with the tip. And you have to kind of figure out how you're going to engineer it being held up straight with the use of tape and popsicle sticks. So I would not necessarily worry about where the finish line is. Look and see how you fit in there first, and then decide where the finish It's the line.